Okay, so what is time series analysis? So let's get started with this. So essentially, the basic idea behind time series analysis is that you want to predict the future, right? So you're measuring something or you're observing some quantity over time, like let's say unemployment rates year by year, and you're really interested in understanding what is the dynamics of the time series and how it evolves in the future, and then you can use this to make decisions, planning, and so on. The difference between this kind of data and other kinds of data analysis data is that you have this time component, right? Very often when you have other data analysis topics, you have data points, but these are often assumed to be independent, right? So if you do image recognition or something, you have these images, but you don't assume that there is a temporal ordering in the images, but that's the main difference for time series data. And often you also assume that the data is sampled at constant intervals, right? So you have measurements which are once per hour, once per day, once per minute, and so on. And this gives you a very rigid structure in the data, which allows you to uncover the dynamics in the data and actually make the prediction. And one very important consequence of this is that the data points are not independent, right? So they're not statistically sampled from processes, but actually, so the data point at a certain time and the next data point in the time series, they're often very closely related. For example, that means if you're already at this level, you cannot really move that far away from the other doing the next step. And actually uncovering this dynamics, and figuring out what is the inherent dynamic in the time series, what is the relation between all these points. This is what makes time series analysis different from usual data analysis, but also I think very interesting. So I will mostly talk about prediction, right? So where they have the time series and you're interested in how the time series evolves in the future, but this is just the most basic and fundamental kind of data analysis you can do. And there are others which are very closely related. For example, outlier or anomaly detection, right? So you have a time series and you're interested in, is the data that I'm seeing, is it still normal data or is there something happening in the system that I'm measuring? So these are very closely related because one common approach to do this outlier detection is actually to make a prediction and then see how far the actual observed values deviate from the values that you have predicted, right? So this is one way to do it. Another very common task is actually to have the time series and then be interested in classifying segments of the time series. So that's sort of, you're not interested in predicting how the time series evolves, but actually taking the data from the time series and then predicting what is actually happening. So for example, if you have data which is measured from wearable sensors, you would be interested in understanding what is the activity that the person who's wearing the sensors is doing right now, right? So these are again, from the method side, they are again very closely related because so whether you want to predict the next outcome or actually another variable which is unrelated, which is separate from the time series, is very closely. It's almost the same kind of task from a data analysis point of view, right? So, and that's so I focus mostly on the prediction tasks because it's very closely related to the other things, but I think it's also good to know what the other kinds of use cases are. All right, so I already talked a little bit about it. So what are the typical examples for time series data? And one of the most common ones is of course financial data. So you have stock data and so on. And people have for a very long time tried to uncover and predict how the stock changes over time, of course, so because if you're able to do this, then you can make a lot of money, okay? And then currently the Internet of Things and monitoring, so we have lots and lots of sensor data from server farms, from energy plants and so on, and it's just too much data for humans to look at. So there's a huge need to understand this kind of data. And then of course, more classically speaking, so signal processing and audio and other kinds of signals, this is also classical time series data for speech and so on. So actually it's a pretty long range of things from really more just technical things, technical measurements, up to, so if you go to audio, right, let's say you have audio from speech and you want to classify it, that means you want to actually understand what the person has been saying, so you're moving into things which are very closely related to interaction between humans and machines and so on. And this is, I think, also one of the reasons why this area is very interesting, because you have this really wide range of applications below.